Hello, am I audible to all of you? Am I audible to all of you? Am I audible to all of you? Hello? Am I audible to all of you? Can anyone please respond? Can anyone please respond? Hello? Yeah, why are you not responding? Am I audible to all of you?
Sir, you are audible.
Okay. Why your classmates have not joined for the class here? Why haven't your classmates joined? Why haven't your classmates joined? Okay, let us start. Can you see my screen? Can you see my screen?
Yes. Yes.
Okay, so let us start. So if you see here, we'll discuss about the application of moments. So what is an application of moments? So first of all, the main application of moments from the engineering point of view is number one is the position of the resultant force, and number two is what reverse. Okay. Now, if you see here, the position of the resultant force by moments, how will you find out? So first of all, you have to find out the magnitude and direction of the magnitude and direction of the resultant force by method of resolution. That means the way we have discussed in the previous chapters how to resolve the forces. Now, the aggregate moment of the resultant force is the algebraic sum of the moments of the given forces that we define. Okay. So here are a few numericals. It could be this. This is simple. You have to just find out what the resultant. In all the numericals, you have to find out the resultant and the angle of influence. Okay. Now we go to another topic. What is a lever? A lever is a rigid bar. Okay. I hope I am audible to all of you. I hope I am audible to all of you. Someone said they can hear me. I hope I am audible to all of you. Hello, hello, hello. Can you hear now? Can you all hear now? Can you all hear now? Hello. Can you all hear now? Hello. Yeah, can you all hear now? Wait, wait, give me. Can you all hear now? Hello. Can you all hear me now? That all of your voices are cracking. What about others? Can you all hear me? Hello. Can you please unmute yourself and reply? Can you all hear me now? Can you please unmute yourself and reply? Can you all hear me now? Yes or no? Please reply. Even if my voice is cracking, then let me. Yes, okay. But I'm not able to hear anyone of you. That's why I'm sitting. Is my voice cracking? Is my voice cracking? Okay, wait then. Wait for a minute. Wait for a minute. Am I able to hear you now? Are you able to hear me now? Hmm? Someone else, please unmute and speak. Network is slow. Yes. Okay, okay. So let us continue. So what is a lever? Basically, a lever is a rigid bar. Okay? It's a straight curved or bent and is hinged at one point. And it is free to rotate about that hinging. So that means what? In a lever, suppose if you see here figure B, okay. Now in figure B, what happens is that this round pointer F, okay. So this F is called actually what? It is called the fulcrum. The fulcrum means what? With this point to this point, dot. Lever is what? Free to rotate. Okay, the lever is what? Free to rotate to this point. Okay, now this free to rotate point, that is the point through which the lever can be free to rotate, is free to rotate. Okay, so that point is basically called what? That point is called a lever. Okay. Now, what are the different types of levers? Number one is simple lever and number two is what? Compound lever. Okay. So what is a simple lever and what is a compound lever? First of all. Now, in a simple lever, it consists only one bar having one fulcrum. Suppose I'm giving you the example of your hand. In our hand, what happens? If you see the elbow, okay? If you see the elbow joint, so in the elbow joint, what happens is that it has only one, you know, joint. That means that the hand can move only in one direction. So that is why we call it what? Simple lever. Okay. Our hand is basically a simple lever. Okay. Then, and a simple lever can be curved, straight, or even bent. So levers of a simple lever are generally classified as what? Lever of first order, lever of second order, and lever of third order. Okay. We'll discuss it in the later chapters. Now, if you go to compound levers, in compound lever, what happens is that the compound lever is basically an assembly, or maybe what you call it, a combination of different types of levers. Okay, that is what is called the compound lever. The compound lever is what basically a combination of different levers. These are what couples an application of this kind of person. Okay. Now, if we go to the next one, okay. So now we are going to discuss regarding equilibrium of force. Okay. So what happens in the previous classes or in the previous chapters, we have discussed regarding, you know, we call it couple, then finding out moment. I hope these topics are almost clear for all of you. Couples, then finding out moments, what to do, all these kind of things. Is it clear for all of you? Can someone reply?
Yes, sir.
Okay. Now we'll go to the next part. That is called what? That part is basically called, your equilibrium of forces. What is actually equilibrium of forces? Okay. Now, now for the basic definition of equilibrium of forces, just remember that if the resultants of a number of forces which are acting on a particle is zero, then the particle is said to be in what? Equilibrium. Or such a set of forces are called to be equilibrium forces. Okay. This means what? Suppose, suppose I'm telling you, we saw a diagram with four planar force system where multiple forces are acting on a particular plane. Now, if these multiple forces are acting on a particular plane, and then you all know how to find out the resultant. Summation of what? Square root of summation of h square plus what? Summation of v square. So this is the what? Formula for finding out the resultant forces. Right. Now, if you are able to find out these resultant forces, then what will happen is that the resultant forces will depict if the resultant forces the summation is zero, then we call this that the forces are in what? Equilibrium. Okay. Now, for the principles of equilibrium, there are three important principles of what? Equilibrium. Now, you can see my screen. We have what? Two force principle, three force principle, and four force principle. So first of all, what is two force principle? Two force principle basically means that only two forces are acting on a body. A particular body, what? Only two forces are acting. And these two forces are what? These two forces are equal, but they are opposite. If the two forces which are acting on a body are equal and opposite, then what will happen? This will be like, these two forces will result to what? How much? Can you tell me? What will be the result of this force? If two forces are acting and they are in equilibrium, then what will be the result of this force? Can you tell me? Can someone unmute and tell the answer? What will be the result of this force? Two forces are acting and they are opposite to each other. So what will be the resultant of these two forces? Can anyone tell me? You have to be interactive in that class. Pick up.
Zero, sir.
Good. Very good. So the resultant will be what? Zero. Okay. Now three forces. Similarly, three forces are acting, then the resultant will be zero. Then it is said to be what? In equilibrium. Then as similar as that, four forces, if they are acting and their resultant will be zero, then four. Okay.
Yes.
Yes. What happened? Any problem? Okay. So we move to the next one. So first of all, we have some methods of finding the equilibrium of coplanar forces. Number one is what? Analytical method, and number two is graphical. So we will basically discuss analytical. So number one analytical method is what? Lamis theorem. Now, the most important part of Lamis theorem is the statement of this theorem. Okay. What does Lamis theorem actually states? So according to Lamis theorem, states that if three coplanar forces are acting in equilibrium, each of the forces is proportional to the sine of the angle between the two other. That means, I'm giving you an example. Look at this. Suppose here, what happens? Suppose P, Q, and R. These are what? The P forces. And alpha, gamma, and beta. These are what? These are the three angles, okay, which are acting between these three forces. This one, and this one. Is it okay? Now, if you see here, mathematically, what we can say is P by sine alpha. That means what? If three coplanar forces, this P, Q, and R, these are three coplanar forces because they are lying in the same plane. Huh? Now, the resultant, that means what? We can write like this P by sine alpha. Why? Because we cut this statement. Then each force is proportional to the sine of the angle between the other. That means what? The angle between, now look, we are taking P force. So if we are taking P force, then the angle between the other two forces will be how much? What will be the angle between the other two forces, Q and R? Can you tell me? What will be the angle between the other two forces? Can you tell me? What will be the angle between the other two forces? Tell me, come on, unmute. Can anyone tell me what is the angle?
Don't know, sir.
Why you don't know? You see the diagram, right? P, Q, R. These are two forces. Alpha, beta, and gamma are the three angles. Now, according to this, what? If three coplanar forces are acting at a point, that means P, Q, R are acting at this center point, right? At this center point, right? At this center point, right? If P, Q, R are acting at this center point and they are in equilibrium, then the forces are proportional to the sine of between the other two. That means what? This force, this P force, will be what? Proportional. That means what? P by sine alpha. Why? Because the remaining two angles between Q and R, the angle is what? Alpha. So as per it is given sine of the angle. That means P by sine alpha equal to Q by sine beta equal to R by sine gamma. Is it clear? Is it clear all of you? Is it clear all of you? P by sin alpha, Q by sin beta, and R by sin gamma. How did it came? Or do you have any doubt? Ask me.
Sir, could you repeat that again?
Yeah, sure. What about others? What about other people? So many people are present, but none of them are responding. This is not good, no? They are simply connected to it and loitering around. What about others? No one is responding. This is very bad. It should not happen. Now here, if you see here, if you look here, look at this diagram. Now this P is there. P is one force that is acting from this point, right? Now P is acting from this point. Now we have other two forces. No? One is Q and what to call it? Last one is what? R. Now the angle between Q and R is what? Alpha. The angle between Q and R is what? Alpha. If the angle between Q and R is alpha, then it's P. Then P by what? The angle opposite to this point is this angle, and you have to take the sine of this angle. So P divided by sine alpha equal to Q divided by what? Suppose this is
Sine
beta.
beta.
Good, very good. And this is gamma. Q divided by what? Sine
R by Q by sine.
sine beta equal to R by what? Sine gamma.
Sine gamma.
Now is it clear?
Yes, sir.
Yes,
Sure. Yes, sir.
Okay. What about others? Is it clear, all of you?
Yes, sir.
yes, sir.
Okay, very good.
Sir.
So this is, yeah, please pick up. Anything, any doubt? Up to this point, any doubt? Any doubt up to this
No,
point?
sir.
Okay, right. So this is how we have, it's called Lamis theorem. This is how we do Lamis theorem. Now, for our part, from our point of view, Lamis theorem is only important. The derivation is not that important. Then just have a look at it. If you have any doubts, you can just ask me about the derivation. Now we will move on to the next topic. Okay.